Hi guys, this is Miss Pulver. We're going to go over this graphing motion nearpod. I can't record on this for a real long time, so it may be a little fast, so you may have to go back through it. Okay, and some of these slides I'm going to skip and go straight to the ones that I really want to be able to explain to you. So notice that you have on this axis, on the y-axis you have your distance, and on the x-axis you have your time. Notice that time can never stop, but distance can stop, okay? So on this one right here, you have this yellow line going a long distance over a short amount of time. So this graph right here is showing a line that it's going fast, okay? This person is going fast because, again, they're covering a long distance over a short amount of time. This person is covering about the same amount of distance over the same amount of time. So this is a constant speed. This is like if I were on the highway going 60 miles an hour for hours and hours at a row. This is a constant speed when it goes up at about a 45-degree angle. This blue line is showing you a speed that is starting off slow because the distance is short but the time is long. And then notice that the distance starts to climb, but the time is a little bit shorter. So this is an accelerating person. This is a person who's starting off slow and then maybe getting on the highway and starting to go fast. So this is a accelerating speed. Again, this one is somebody that's going fast. This is a constant speed, the red one. The blue one is somebody who's starting off slow but is accelerating. The green line is somebody who is going a constant speed. And then notice the flat line right here, this horizontal line. Notice how their distance stops and yet their time goes on. Again, we can't stop time. So when you see a flat line like this, that means they stopped. Then the line went back down, so time kept going, and notice that their distance kept going. They started off right here at their house or wherever they were. They went for a constant speed. They stopped, and then they went back to where they started. So this shows a constant speed, a stop, and then a constant speed back to where they started. I'm going to skip this part. I don't have any way to put anything on these graphs right now. So this one again is showing a constant speed. Notice that they went 10 meters in 1 second, and then here they went 20 meters in 2 seconds, 30 meters in 3 seconds. So they're showing a constant speed as they go along. Every 10 meters, they're going 1 more second. Okay, again, this one also is showing a constant speed. They're going the same speed over the same distance. This one is showing that they stopped. The distance stops. They stopped at 40, and yet the time continues because, again, we can't stop time. Okay, so this one will be showing somebody that's going at a constant speed. Say they leave their home, they go to Walmart, they stop at Walmart, the distance stops, but the time goes. And then let's say that they realize that Lowe's is about to close. So now they go at a fast speed. Okay, notice that over 1 second, they end up going a distance of 30 meters. So now they're going fast. So when the line starts to go up steep like this, they're going fast. So a constant speed, a stop, and then going fast. Okay. This one again is showing that they started off slow. Whenever the incline is less steep, that means that they're covering less distance over more time. If you're covering less distance over more time, you're going slow. And then they start to speed up. They start to cover more distance, notice, over less time here. Okay, so again, this is a person who would be going a constant speed. They would stop, and then they would go back to where they started. Let's say they started from home, they went to Walmart, and they went back at a fast pace back home. This line is more steep. Okay, so this kind of shows you what I already went over. This one, they would be going slow at first and then accelerating. They would stop, and then they would go at a constant speed back to where they were going. So today, when it's asking you to do the graphing motion graph, you could show Mrs. Pulver left her house to go to school. So you would show me kind of starting off slow from my driveway and then getting faster as I went on the highway. She stopped at school for 8 hours and she worked I know that doesn't match down here, but that's what she's going to say. And then she drove home at a fast pace. Or, well, this would be more of a constant pace. Okay, so again, look at these speed graphs. Look at these as your reference for what you're going to be doing today in graphing motion. Okay, now I'm going to go back to our dashboard, and I'm going to look at what we're doing today on Thursday, graphing motion story. And I'm going to pull up the link to the document. Sorry, it's taking a long time to load. So today's, it says, using your notes from graphing motion, nearpod help you complete the assignment. So you could do something like, as soon as it loads, I could get on the tools. Remember that you need to go to File and make a copy for your own copy, okay? And then right here, you could write something like, I left my house and went to the park. I stopped at the park, and then I went back to my house, okay? And then you would draw something like a constant speed, a stop, and then going back to your house at a constant speed. Just for the sake of time, I'm not going to open it up and show you how that would work. You can, when you get into Google Docs, when you open it up, you can use the tools here to, well, once you make a copy, it'll show you tools to draw that. Or you can use shapes to make lines. You can also download pictures for your illustration, and then you can share that with your teacher. Okay, I hope that helped. If not, reach out to me and let me know. Bye.